Hello, my name is Mike Ferentz. I am one of the math tutors from Seeds of Literacy, and today I would like to share a lesson with you on working with triangles. Hope you'll bear with me. This is my first attempt at a video lesson, and I prepared some slides and would like to do some problems with you. And so let's give it a try and let's get started. So first I'm going to share my screen. Okay. So this is my topic, working with triangles. Sorry about that. So it'll pop up in a second. Oops. Let me just go back. Okay. Working with triangles. So in this lesson, I want to talk about types of triangles and how to identify them. We'll talk a little bit about measuring the angles and sides of a triangle, as well as the perimeter and area of triangles. So triangles are a unique shape used throughout all of math. They're a very common shape, right up there with circles and squares and rectangles. And it is a polygon, just happens to be a three-sided polygon. And we want to take a look at some of the laws and properties for measuring triangles so that we can see how they apply to real world situations. And we'll finish up with a little bit of a discussion, but not much, about right triangles, as they are one of the most important aspects of the study of trigonometry and calculus. But we're not going to get into that today. However, we're going to take a look at how that leads into that study. Okay. So moving on. So let's take a look at the different types of triangles. These are the four basic. There are more, but I just want to take a look at the four basic ones here. An equilateral triangle, as you can see from this graphic, has three angles all of equal measure. So the 60 degrees shown here, that's the measure of the triangle. And this triangle is depicted by the letters A, B, and C. So A refers to this angle, B refers to this angle, and C refers to this angle. Equilateral means that the three sides are all even. In this case, they are all 3 inches. You can also say that this triangle is equiangular because all the angles have the same measure of 60 degrees. But it's equilateral because the sides are all equal. An isosceles triangle has just 2 equal sides here. In this case, it's referred to as BA and AC. BA means the side that's between the angle B and the angle A. AC is the side between angle A and angle C.
Sorry, I couldn't quite hear you.
Sorry. So in an isosceles triangle, there are 2 equal sides and a base. And the angle opposite the base, which is A, is called the vertex. Scalene triangle is kind of unique because it has no equal sides and no equal angles. And then finally, the right triangle, again, one of the real basics of higher geometry, trigonometry, and calculus, always has one angle that is 90 degrees. In this case, it's angle Y. It can and right angle can also be an isosceles or scalene triangle. But because of the fact that it has that right angle, it's referred to as a right triangle. And the right triangle is 90 degrees, which means that in this case, yx is perpendicular to yz. Okay. Now let's take a quick look at the relationships between the sides and the angles of a triangle. So this triangle here is considered triangle ABC. Again, the angles A, B, and C. And in this case, the measure of two of the angles is given. The measure of angle A is 49 degrees. The measure of angle C is 34 degrees. One of the given facts of geometry is that the three angles of a triangle all add up to 90 degrees. So in this case, if we want to find the measure of angle B, we can do that by adding angle A and angle C. So if you add 49 and 34, we come up with 83. So to find the measure of angle B, we take the total of 180 and subtract 83 from 180 and come up with a total of 97. Therefore, the measure of angle B is 97 degrees. So it's a very important fact in triangles that we understand that the three angles always add up to 180 degrees. So just to go over that quickly again, we have 49 for this one and 34 for angle C. You add those two together, 49 plus 34, and you get 83. So to get the measure of angle B, we subtract the total of these two angles, which is 83, from 180, and we come up with 97. Moving on. Here are a few more ways that you can, just a few more examples of finding the measure of angles in a triangle. Here's another one that has, there's no picture shown, but if a triangle had these two angles measured of 35 and 75, and you knew that, the question would be to find the measure of the third angle. And again, if you know the two of the angles, you can add them together and subtract that from 180 degrees to find the measure of the third angle. And this problem does that for you. 35 and 75 plus x, which is the missing angle that we're trying to find, equals 180. And 35 plus 75 equals 110 degrees. Plus x equals 180. So in order to find x, we just subtract 110, and we find that the measure of the missing angle is 70 degrees. Another one, a very common angle, once again, we'll get back to that 90 degree, an angle that has a 90 degree, a triangle that has a 90 degree angle, that's a right triangle. So this problem is simply telling you a right triangle that also has an angle of 50 degrees. You do the same calculation. You take the two known angles, add them, plus the third angle, it will add up to 180 degrees. So 57 plus 90 equals 147, plus the third angle has to equal 180. And you subtract 147 from both sides, you find that the missing angle is 33 degrees. Before we get into finding the perimeter of the triangle, I want to skip up out of there for now and I want to go into the lesson pack and do a few of these problems. So I'm going to use my writing tool here. I'm going to do it in blue right over here. So let me select the pen. Sorry, now we got it. Oh well, let's try a few of these. So we have a problem of naming each triangle, whether it's equilateral, isosceles, or scalene. So let's look at number one. And we see from number one that we have a 90-degree angle right there. So that immediately tells us that this is a right triangle. Okay, because it has a 90 degrees, you don't have to go any further than that. Actually, it also, I'm sorry, it does want you to, this problem does want you to identify it as a scalene because it does not have any equal angles. So it is also a scalene. Problem number two, we see that we have two angles of equal value, equal measure. And we know that when we have two angles of equal measure, we have an isosceles triangle. Now, I'm just going to put I. Now we know that we can determine, we don't know if this is a right angle right here or not. So the way we're going to do that is we're going to add 34 and 34. And that equals 68. And if we subtract that from 180, which is the total measure of all three angles of a triangle, we come up with 112. So we know that this angle right here is going to be 112, which means it's not 90. So this is not a right triangle. So I'm going to circle this one as being a right triangle, but this one is not a right triangle. So moving over to number three, we see we have three angles all of equal measure. And we know that an angle that has all three angles of equal measure is an equilateral triangle. So let's put an E in there. And then finally, moving over to number four, we don't have any right angles there. You can just see by the shape. And we know that none of the sides are the same, which means none of the angles are going to be the same, and this is going to be a scalene. Okay. Now let's go to finding the value of triangles. So again, using our 180 property, we have three angles here. B is 54, C is 59, and we're trying to find A. And we know we could do that by taking 180 and subtracting the sum of the other two remaining angles. So 54 plus 59 equals 113. And then we do the subtraction there. We come up with 67. So we know that the value of angle A, which is what we're trying to find here. This little angle thing means angle A is 67. And we want to put in the little circle up there, degrees. Same thing here. We have 61 and 54. We'll just add those up. That's 115. So we want to subtract 180 minus 115. It's 65. So the answer is 65. We'll just write that in, 65. And again, we want to indicate as degrees. You always want to, in geometry or really any other math, when you're writing down a unit of anything, you always want to determine what the unit is that you're measuring and indicate that, whether it's inches or pounds or feet, in this case, degrees. And so number 9, it looks like it's 90 degrees, but just to verify, we'll add 52 and 38. Is 90, which means that 180 minus 90 is going to be 90. So although it looks like it's perpendicular, we don't know for sure until we measure these two angles, and indeed it is. And so your answer there is 90. So just do a few more here. Let's get rid of the drawings there. Let's move on down to so same thing here. We've got looks like a right triangle, but it's not, because see right there, it's 92 degrees. So 92 plus 46 is going to be 138. 180 minus 138. 42. Answer for angle B is 42 degrees. This is looks like a scalene triangle here. We've got a pretty big angle at 125 and 20. I can do that quickly. It's 145, and 180 minus 145 is going to leave me with 35. And then we've got same situation, 53 and 45, 98. And so the missing angle, which is S, is going to be 82. Okay. So now I'm going to go back to my PowerPoint. That. Oops, I gotta get rid of this drawing tool somehow. Yeah, okay. Sorry about that. As I mentioned, this is my first time, and I'm struggling a little bit with, yeah, I gotta go back to the pointer. Okay, there we go. Back to my PowerPoint. Let's get this moved out. Move that out. and PowerPoint. Okay. Sorry about the confusion here. Let's erase all drawings and attempt to get back to my PowerPoint, which is here. Ah, good, finally. Okay, see, I can do it. All right, so I mentioned earlier finding the perimeter of a triangle. The perimeter of a triangle is simply the distance all the way around. So in order to find the perimeter of a triangle, you just add the three sides. So in this example here, we have 3.1 yards for this side, 2.5 yards for this side, and 5 yards for this side. And so P, let's let P stand for perimeter. The formula for finding the perimeter of a triangle is side 1 plus side 2 plus side 3. Where S1 stands for side 1, S2 stands for side 2, S3 stands for side 3. You add the three of them together, 5 plus 2.5 plus 3.4, and you get 10.9. So now let's try this problem here, where we have a triangle with three sides, 9 centimeters, 8 centimeters, and 12 centimeters. So let's see if I can get my pen back. Looks like I can. So using this formula, P equals side 1 plus side 2 plus side 3. We know that side 1, let's just call this 9, is side 1. Let's call 8 side 2. And let's call 12 side 3. Add those three together, you have 12 plus 8 is 20, plus 9 is 29. So your answer, the perimeter represented by P, equals 29. And again, let's make sure we use the units, 29 centimeters. So the perimeter of this triangle is 29 centimeters. That's pretty much all you need to know about finding the perimeter of a triangle. Okay, let's go back to my pointer and move on to the next slide here. And oops, let's erase drawings. And now we want to talk about finding the area of a triangle. And this is a function that you can do often in your daily life when you're trying to find the area of a space that's not a square, or it's not a circle, or not a rectangle, but a triangle. So let's say you're putting in carpeting in an area in your home that's a triangular shape, or you're building a flower bed in the corner of your yard that's a triangular shape, and you want to know the square footage of that shape. Well, if it was a square, it would be pretty, or a rectangle, it would be pretty simple. You just multiply the base times the height. But if you look at what we have here, if you think of a triangle of being three-sided, it's really, let me get my drawing tool back in here. A triangle is really like half of a rectangle. So what I have here in this triangle are two equal. If I had another equal triangle to that side and flipped it over to here, I could make it into a rectangle. So in order to find the area of that rectangle, I would multiply the base times the height. The base being from B to C, 6 feet. The height being from B to A, which is 4 feet. That's pretty simple, 24. However, we're not trying to find the base of a rectangle. Get rid of that. We're trying to find the area of, I'm sorry, we're not trying to find the area of a rectangle, we're trying to find the area of a triangle. So the formula for finding the area of a triangle is given by 1/2 the base times the height, where b is the base and h is the height. So in the case of example 1 here, we have a base from b to c of 6 feet, and we have a height of 4 feet. Now in this case, this little indicator right here means that that's a right triangle. That means it's a right triangle. So we know that this is your base, this is your height, and this is your base. And I'll explain more of that when we get to the next example. But so if we take the formula that we have up here, 1/2 base times height, so A equals area equals 1/2 the base times the height. So we'll just bring that down and say 1/2 times the base, which we know is 6 feet, and the height, which we know is 4 feet. And if you multiply 6 times 4, that's 24, times 1/2 is 12, and your answer is 12. Now, this was an easy one because it's a right triangle. But if we move on to a non-right triangle like this one, this looks like to me like it's a scalene triangle. We don't have a perpendicular to measure the height, but we do have here a measure of a line that goes from the vertex to the opposite side, and that is the height of the triangle. And we know that the base is 5 and that height is 3. Once again, just hypothetically, so you can understand why the area of a triangle is 1/2 the base times the height. If I drew this, oops, that was pretty bad. If I drew this as enclosed it all, you can see that this area is equal to this area. Change colors here. And this area is equal to this area. So if I have 2 of these and 2 of these, that gives me the area of this rectangle. But I only want the area of the triangle, and I know that the area of a triangle is 1/2 of the area of what would be a rectangle if you filled it out. Get rid of that. So I know that my base is E to F, which is 5 yards, and I know that my height is 3 yards. So using the formula of 1/2 base times height, area equals 1/2 base times height, we just plug in the values that we know. 1/2 times 5 times 3. 5 times 3 is 15, and half of that is 7.5. Okay, and then one more example. Then this one's a little different because the height is actually outside of the triangle. Here it's in the triangle. So in order to find the height here, I have to draw a little dotted line out to where it would be a perpendicular right here, because the height has to be perpendicular to the base. It has to be a right angle to the base. Make sense? So again, using the formula, area equals 1/2 base times height, we know that the base is 9, even though we're not measuring this part here, because the only part of the triangle we're measuring is the part inside of the 3 sides. So the base is 9 and the height is 6. And again, plugging it into the formula, capital A, which is for area, equals 1/2 base times height. 9 times 6 is 54, times 1/2 is 27. Now, in the three examples given here, because we're finding area is always given in square feet, square yards, square inches, square meters. So in here, it's shown as square feet, SQ being square, here is square yards, here it is square meters. So meters, m to the second power, it means square meters. You can also write over here 7.5 yards to the second power, and it would still be correct. These are just different ways of showing area. One last thing I'm going to do here today is we're now at about the half-hour mark. I want to go back to, yeah, that worked out. Okay. Put my pointer in there so I can go down to, oops, let me erase the drawings. Let's go down and see if we can do a few problems. And this is from the packet that everyone has. And I want to see if we can do a problem or two in finding the area. Yeah. There's the three we just did. So let's do these three. Very similar to the ones we did. So let me get my drawing tool back, pen. So this one seems pretty simple. We know that the area of a triangle equals 1/2 base times height. And so we know that equals 1/2 base of 7, that's times the height of 4, 7 times 4, 28 times 1/2 equals 14. And this is centimeters. And because we're finding the area, we know that we have to write it as centimeters squared. So the answer is 14 centimeters squared. This problem is similar to the other sample where we have a base of 12 and this looks like a right angle here. And so we know that this is our height. So we got A equals 1/2 4 times 12 equals 1/2 of 4 times 12. 4 times 12 is 48. 1/2 of 48 is 24. And it's feet squared. Or we can also write 24. That's not very good. 24, we can write it like this, square feet. And finally, another one with the right angle being outside of the triangle, but still it's clear that the base is 3.2 and the height is 3. So let's just do area equals 1/2 times 3.2. Ooh, that's not very nice. Times 3. And I don't want to do that in my head, so I got my calculator right next to me here. 3.2 times 3 equals 9. No, it doesn't. 3.2 times 3. Sorry about this. 9.6. I had my calculator set without the decimal point, so 9.6 divided by times 1/2 is 4.8. So just getting off the subject a little bit. It's always important to make sure that you're doing your calculations correctly. Even though I have my calculator, I had it set to no decimal points. So when I was getting an answer, I got an answer of 3.2 times 3 equals 9. I know that's not true because I know that 3 times 3 is 9. So 3.2 times 3 can't possibly equal 9. And that's yards. Squared. So it's 4.8 yards squared. All right. Let's erase all that. I just want to show one more thing in today's lesson and we'll be done. And that is, I mentioned that the right triangle is a key figure in higher math. And so this is something that you're all going to get into later, the Pythagorean Theorem. And the Pythagorean Theorem uses a right triangle. And one of the things that the Pythagorean Theorem tells us is that if you know the two sides of a right triangle, you can find the third. And the way that you do it is you square those two sides, add them together, and take the square root. Don't have to remember this today because this is just a tip about future usage of triangles. But so if you the Pythagorean theorem says that a squared plus b squared equals c squared. And a is 3, so 3 squared is 9. B is 4, 4 squared is 16. 9 plus 16 is 25. The square root of 25 is 5. And this is a 3, 4, 5 right triangle, which is very common in trigonometry. But that's all I'm going to say about that today. And that pretty much concludes my lesson today on working with triangles. I hope that this is helpful, and I hope to see you again in a future lesson. So thank you very much for, I'm going to stop sharing, for joining in today, and I'll see you again soon. Thank you.